the nucleate for bismuth is given. State the composition of the nucleus. So the number of protons is nothing but its atomic number, which is 83. The number of neutrons is its atomic mass minus the atomic number, which is 214 minus 83, which gives the number of neutrons as 131. Now bismuth decays into polonium using a beta particle. Beta is 0 minus 1, which means polonium becomes 214 and 84 to balance out the equation. The count rate of a sample of bismuth is 360 counts per second. Predict the count rate from the sample after 60 minutes. Now, moving on, we understand that its half-life is 20 minutes. Half-life is defined as the amount of time taken for a radioactive material to reduce its amount and its count rate to half its initial value, which means if the initial count is 360 counts per minute, after a time interval of 20 minutes, it will reduce to half the value, that is 180. Another 20 minutes means it will reduce to 90, and another 20 minutes, which means a sum total of 60 minutes, means it will reduce to 45, not 44. 45 counts per minute. So the final count rate is 45 counts per minute. State two of the social and economic and environmental issues involved in storage of radioactive material with very long half-lives. Now, when storage of radioactivity with very long half-lives comes into the picture, we understand that it has a great environmental impact because the risk of leakage and also wastage of farmland, which is instead used to safely store and prevent the leakage of radioactive materials with very long half-lives. State in terms of particles in each nucleus how the nuclei of two isotopes of the same element are different. The nuclei of two isotopes of the same element have the same number of protons, but different number of neutrons. This is how two isotopes of the same element are different. Next, the figure shows the nuclear number against proton number. The nucleus bismuth, that is 21283, is plotted on the graph. On the figure, plot a clause labeled Q for the nucleus form when 212 bismuth 83 nucleus emits an alpha particle. If it emits an alpha particle, its atomic number will reduce by 2 and its atomic mass will reduce by 4. So 83 becomes 81 and 212 becomes 208, which is approximately here. And it becomes a new element, obviously. Plot a clause label when it emits a beta particle. When it's beta particle, its atomic mass remains the same, but its atomic number, in fact, increases by 1 in the second instance when compared to the first. Next, the half-life decay of bismuth is 60 minutes. A sample of bismuth is placed at a fixed distance from a detector. Initial measurement of the count rate of the sample is 2400 counts per minute. The initial reading is 2400. Calculate the count rate after 5 hours. We know that the half-life is 1 hour, which means after 1 hour, it will reduce to 1200. An additional 1 hour will make it 600. An additional 1 hour will make it 300. An additional 1 hour will make it 150. An additional 1 hour, which is a total of 5 hours, will make it 75 counts per minute. So the final reading is 75 counts per minute. Next, a technician sets up a radiation detector in a university laboratory for use in some experiment. Even before the radioactive source is kept for experiment, the detector shows a low count rate. This is due to background radiation, which is present in every environment imaginable. A radioactive source that emits alpha particles is placed in laboratory and source is gradually moved closer. At first, the detector continues to register low count, sometimes slightly less than the count rate registered. The count rate suddenly increases to a very high value when the source is very close. Explain these changes. The reason why the count rate is a small value up until a certain point is because of background radiation, as explained before. And the reason why the count rate doesn't increase up until you come very close is because alpha particles or alpha rays have a very short range, owing to the fact that they are very heavy and highly positively charged. And this is a this is a simple reason why the alpha particles, which have very short range, are not detected by the detector up until the detector comes very close to the source. And at this point, the detection is within the range of alpha particles. And this is why there is a very sudden spike or a sudden rise in the value of amount of radiation detected by the detector. Alpha particles pass between two parallel plates. They continue to the detector as shown. A positive charge is established on the upper plate and negative on the lower plate. Alpha particles themselves are positively charged. So obviously they are repelled by a positive plate and attracted towards the negative plate, or the trajectory path taken is a downward curve as shown. State what happens when count rate registered. Since alpha particles have a trajectory path that is taken by them, they no longer reach the detector. Since they no longer reach the detector, the count rate across the detector decreases to such an extent that it only shows background radiation. Only shows background radiation.